while introduce Kaneko-san from the Space Agency Japan. And the background is like, if you remember back in 2012, maybe 2010 or 10 years ago, when Vint called me and the NASA JPL started to work, and the ITF started to work for the new protocol with a long latency. So in order to communicate with the moon, it's a 2.6 second latency, and also they would like to communicate with Mars. And the things has been changed since the past 10 years, and it's becoming a reality. A lot of commercial entities trying to go to the moon and doing the work, construction company, automobile company, and other things, and the people wants to live, and the people wants to do the business on the moon, and then so we need the internet. So one web on this planet, is that going to be another web for the moon and the Mars, or is that a part of the this planet's internet? So those subject is now led by the organization called Interplanetary Network, SIG, whose president is Kaneko-san. So go ahead,
Okay,
Kaneko-san. Thank
so
you very much.
hello everyone. I'm new to the community, but thanks very much for having me today. Actually, I met June just 1 year ago when we started talking about the interplanetary internet. And June got really, really excited about the topic, and we've been collaborating since then. It's been a year. We've done a lot of events together, like Interops and IGF and IPNIG. So it's been a wonderful journey so far with June. So thank you very much for inviting me. And of course, to the organizers, I believe this is a very important milestone for the Web Consortium and also for the Internet. So thank you for having this opportunity to meet. And speaking about my career, I actually work at the Japanese Space Agency, as he introduced. And I work on a lot of moon exploration programs and Mars exploration programs. And I also lead a US nonprofit, which is called the IPNSIG. And it's basically a chapter that operates under the Internet Society, and we have like 1,050 members already. So we're actually endeavoring to expand networking to interplanetary space. And there's a lot of momentum and lots of excitement in space exploration today. So I'm really happy to share our enthusiasm and how the internet community can play an important role in this endeavor. So I want to start by looking back in our footage first on how space exploration developed over time. So more than 50 years ago, the Apollo landed on the moon. It was Apollo 11. It was in 1969, and our greatest hero, Neil Armstrong, sent us that famous quote that humanity has reached the lunar surface. And at the same time, there was another milestone where communication also reached the lunar surface. But in this era, during the 1960s and the 1970s, it was more of a space race between the United States and the Soviet Unions as to who gets to the moon first. And the United States actually came there first, but actually there were no actual collaboration. It was kind of a competition in this phase. And then we started building the International Space Station. This is a truly international effort. It's a magnificent platform that was built by 15 countries, including the United States and Japan and Canada and Russia, and also many other European countries. It's still up in orbit, and there's a lot of experiments that's being undertaken and a lot of technical demonstrations in order to get prepared for lunar exploration. So around the 21st century, we kind of hit the regime where space is a field of international collaboration. And then the commercialization came. If you turn on the TV or YouTube, you would see Elon Musk's rockets flying very often. For instance, the Falcon 9 rockets or the Dragon spacecraft, they are flying very frequent to the International Space Station to resupply cargo and also crew to the station. And also Blue Origin, run by Jeff Bezos, has a rocket and doing kind of a similar business there. And Blue Origin also has plans to deploy commercial space stations in the future. So things are really progressing. So it's now considered that space is no longer a field for only the nation states, but also for the industry. And now humans are extending even farther. There's a global interest on the moon again. The nation states are basically drawn by their inspiration and national pride and scientific potential of the moon. And the private sectors are also motivated by the economic benefits of the moon. And this time, we're going to the moon with international cooperation and with the industry. And this time, we're going to stay, not a one-shot mission like Apollo. So we're going to stay. So that's a kind of a significant distinction between our previous visit to the moon. So one of the driving impetus that's pushing this endeavor is the Artemis program, which aims to put humans back on the moon by the end of 2026. It's a U.S. Initiated program, but a lot of countries are participating, including Japan. There are already 36 countries who have signed the Artemis Accords, which is a set of common principles in order to preserve the peaceful and safe use of the moon. So here I want to show you a quick video of the Artemis program. I'm sure you may be well aware of this program, but this is a very good video.
It's a new day in space exploration. As we sail on this new cosmic sea, there's so much to learn. There's so much to be excited about.
Artemis is different from anything humanity has ever embarked on before. And we will discover life-saving, earth-changing science and technology along the way.
We're delving deep into what science can be achieved by humans working together with robotic capabilities and future infrastructure to support a long-term human presence at the moon.
The Artemis generation stands ready to return humanity to the moon and then to take us further than ever before to Mars.
Onward and upward.
Okay, isn't that fascinating? So we're going back to the moon and we're going even farther to Mars. So speaking of the moon first, I want to show you a map here. So the Apollo actually landed 6 times in the past, and it kind of ended in the equator zone, the center zone of the moon. And actually, the Artemis is going to the South Pole because scientists say that there is water or ice embedded under the South Pole. So if we were able to find water or ice there and then extract them and maybe purify them, they can be drinkable water. Or if we can electrolyze them and break it down to hydrogen and oxygen, oxygen can be, breathable air, and hydrogen and oxygen is used for rocket fuel, for modern rockets. So if you find water there, it really not only allows you to stay on the moon, it allows you to give you the capability to go even farther beyond the moon domain. And just recently in January, the Japanese lander SLIM had landed on the lunar surface, which was a great success. And Japan became the 5th country to land on the moon. So that was a great success. And as a SLIM basically demonstrated a pinpoint landing capability at 100-meter accuracy, and that's why it has a nickname of a moon sniper. So in the future, if scientists would say that I want to go to that crater and then I want to investigate that rock right there, then here's the technology that can do that. So it was a really true advancement in space exploration for us. And if you have seen the news, actually, the SLIM had survived 2 or 3 lunar night times already, although it wasn't designed to do that. Typically, if you go under nighttime, you would be subject to extreme environments where the temperature could drop below minus 170-ish around. So that was basically a bonus for us, and it's still functioning. And of course, our United States friends and the Indian friends also landed on the moon. The Indian Chandrayaan-3 landed August last year. And just recently, the Intuitive Machines, which is a private sector at the United States, also landed on the moon. So that was another big history there. And looking ahead, when we think about long-term presence on the moon, you're basically going to need a whole lot of infrastructure. You're going to need mobility or power, like fuel plants and food production, and how you're going to manage wastes, and you're going to need construction systems, and so on and so forth. So what's really fascinating here is that lots of private companies are already investing in these assets and doing a lot of research and development in order to provide these lunar services. For example, the one on the top left is the what we call the lunar cruiser. JAXA and Toyota is going to develop a big car on the lunar surface. And, Japan always has the best cars in the world, right? So, so I wouldn't be surprised if the American astronaut will be driving a Toyota, even on the lunar surface. So things are really materializing. So it's absolutely evident that lunar communication would play a very, very important role, whether if it's for science or exploration or commercial activity. And things are starting to sell off in reality. It's no longer a fantasy, and people are getting really serious about setting up a lunar comm infrastructure. NASA has a program called the LunaNet, which is an acronym of Lunar Internet, and the European Space Agency also has a similar program called the Moonlight. Both of them have plans to provide communication and navigation services for users on and around the moon. Navigation is like GPS-like system. It's important that you know where you are. You don't want to get lost on the moon. So these things are actually in development right now. And there are hundreds of companies that are interested in joining this LunaNet endeavor. And this is just a list I created 2 years ago, the companies who have participated in one of our workshop events. So I really won't be surprised if the list would have doubled or tripled in the next coming years. And for example, the telco companies like KDDI and Nokia is planning to deploy 4G services on the lunar service. And JAXA is also assessing, this is my agency, JAXA is also assessing lunar comm and navigation architecture assessments and doing a lot of research on optical communications such as high power antennas and high power amplifiers and modulation technology and etc. And China also has plans called Kwakiao. I'm not sure if I'm pronouncing this correctly, but it was a plan that was revealed at the last year's International Astronautical Conference. They have a very holistic plan. First, they said that they will establish Earth-Moon link, and then in the end, they will realize a common nav service that would cover the entire surface of the moon. So is that Kwakiao? Is that how you read that? Chuchao, okay. 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 Everyone was saying Kwakiao. So okay. So this is the solar system internet, which is a concept that Vint and myself is promoting at the IPNSIG. I would say this is the kind of an end state in the next 30 years or so. Different types of networks, space agencies networks like LunaNet and Moonlight, and also the private sector's networks like KDDI and Nokia. And there could be also academic networks, and they all join together to form a single network backbone to connect the Earth assets and the Moon and the Mars assets. So that's the final goal, I would say, and it's basically IPN6's vision to work toward a common structure like the internet, because we already know from the experience of the internet, by having a common structure, it becomes a really, really powerful tool. So this is what we are working toward. And this is a personal reflection that I sometimes use. What is about to happen in space networking is kind of analogous to the old days of the internet. In 1983, the ARPANET and SATNet and the PRNet, they all joined together using TCP/IP, although they were different types of networks. So to me, what is about to happen in space and what we are about to witness in space is very similar to this, where many types of different networks provided by different actors will start interconnecting with each other. But that sounds pretty easy on PowerPoint, but space is very difficult, and there are several challenges in deep space communications. If you look at space debris, there are more than 100 million objects out there, and if you have an unlucky day, you would get hit, and you can get damaged, and the network could be easily damaged, right? So that is one thing, and then we also have a natural disruption like solar flares and cosmic radiation, and these could actually easily damage the hardware on satellites and the comm signals itself. And there's this other problem that you need to deal with astronomical distances. Whether you like it or not, the speed of light is too slow. So if you look at the picture, there's a 40-minute round trip time between Mars and Earth. So TCP/IP doesn't work very well. The window buffers don't work very well. So we need a new technology to do that. And there's also planetary motion, what sometimes we call that orbital mechanics. The planets move around. So if a satellite will go behind the planet that's moving around, then your connection will be disconnected. And we haven't figured out a way to stop this planetary motion yet, so that's inevitable. And from a protocol layer, in order to compensate with these challenges, one of the protocols that are being in development is called the bundle protocol. And I'm sure some of you are familiar with this. And the IETF is working on this. And then there's also a group called the CCSDS, which is an acronym of the Consultative Committee on Space Data Systems. So there are lots of standardization work being performed on these protocols. And here's another interesting topic. So we have the internet today. So will there be a moon internet? So since the internet technology matured so much on this planet, there's this idea that why don't we use this on the moon? It will be cost effective, light. Space is always expensive when you try to develop a space rad hard rated component. But if we can infuse the commercial technology onto the moon, that will be a good idea, actually. So these are questions that are being raised amongst the space agencies and the private sector, because we already have plans for LunaNet and 4G, 5G, and local Wi-Fi, and etc. So people are serious about this. But there are lots of things that needs to be sorted out, right? Like, does it connect with the Earth internet, or are we using IPv6 space? Or will there be any autonomous systems on the lunar surface? And if so, how does the routing work? Will we be using BGP like on Earth? Or what about DNS? Are we doing DNS lookups? Are we web browsing? Are we doing YouTube from the moon? So these are all questions, open questions that we need to figure out and sort out before it gets too late. So that's why I'm talking to you on this topic, okay? And actually, I don't want to overwhelm you with so many challenges, but here are some more examples that people are talking about. So first of all is about the universal standards. So for example, lunar time, as we need precise time on the moon for precise landing and to conduct our missions, and for navigation services for sure, time becomes a really critical issue. And just recently, the White House had directed NASA to set up a LTC, which is a coordinated lunar time, which is equivalent to the Earth-based UTC. So we should carefully follow these progress and discussion as we move forward. And if we were talking about the solar system internet, then we might need to set up a solar system coordinate, the XYZ system, in the future. Nobody has really thought about this yet, but I think those are important things. And in order to realize SSI as a common structure, the lessons we learned from the internet becomes really, really critical. For example, projecting the bottoms-up process that we have at the IETF, or the multi-stakeholder policy-making process. These are really, really important things to me that has really contributed to the sustainability and evolution of the internet. So I think this is no different with the solar system internet as well. So a lot of things to learn from the internet. So anyhow, this is probably my last chart. I think on this very important milestone at W3C, I hope we share that space is our next frontier for the internet. Yes? Okay. And I'm just really hoping that more engagement from the internet community would really, really help and will be absolutely the key to success to realize an infrastructure, even in space. So let's do great things together. Thanks very much.